Hi guys, welcome to my channel. Today let's solve at either lead code question. The description of the question is as follows: that we were given a string word which is consisting of lowercase English alphabets, and telephone keypads are keys mapped with distinct collection of lowercase English letters. You might have seen that with your grandmother or grandfather as well, which can be used to form words by pushing them. Great. Now, for example, the key 2 is mapped to ABC. So if we need to type any letter, then we need to push 2 one time to get A, push 2 two times to get B, push 2 three times to get C, right? But each letter must be mapped exactly to one key. That's correct, because you might have seen in any mobile as well that A can be mapped to only 2, and it couldn't be mapped to 3 as well, because then there would be confusion and we couldn't incorporate all 26 English alphabets. And also we were given that you need to find minimum number of times the keys will be pushed to get a string word. Okay, return the minimum number of pushes needed to type word after remapping the keys. Okay. So given this, we possibly have a chance to remap the keys, in the sense that we knew it as a universal truth that ABC will be mapped to only 2, but to get a fruitful answer, depending upon the given word, we could have 2 as A, D, E, 3 as B, F, G, and so on. So that depends upon our choice, so that we need to press, or we need to push the keys minimum number of times so that we could get this word. And we could map our keys accordingly with our characters to get this word. So, but only given one condition is that 1*0# now also will won't map to any keys, and the number of alphabets that are mapped to a key should be same, in the sense that for 2 there are only 3 alphabets matched earlier. So now also it would be 3 only. I couldn't say 2 will be having 5 alphabets matched, and that's wrong. So we couldn't have this case. So only things to consider is 1*0# will still have no keys mapped to it. Sorry, no alphabets mapped to it, and number of alphabets that are mapped earlier to a key should remain same. So what would be my approach of doing this problem is fairly simple. I'll first of all, you knew that we need to get a minimum number of pushes. In order to get minimum number of pushes, then push we need to push the characters that are repeated more number of times, probably in one go if it's possible. In the other way, if a word is having, let's say this example where word is having only A's and B's, and it's having 3 A's, 3 B's, 2 A's, 2 B's. Okay. So in order to get minimum possible answer, if I left my keypad as it is, then for pushing A, I'll need to press one time, A one time, B one time, sorry, B two times, B two times, B two times, A one time, and B two times and 2 times. But we aren't using the condition that's provided to us that we could remap alphabets to keys. In other way, if I left A as it is and B, instead of mapping to 2, if I map to 3 as the first letter, then for B also only one press is sufficient. So here also only one press will suffice my condition. And now the minimum answer would be all ones only added together, not in the case of earlier where we are having twos as well. So we need to first of all count a frequency of alphabets that are repeating, so that we could proceed whether to keep the alphabet as it is, or whether we need to remap it to a newer number. So for happening that, we are already having our lowercase alphabet, so we'll just have a count vector with 26. Why 26? Because we knew that alphabets A, B, C, and so on will be having some ASCII characters. So I'll just I'll show you what ASCII would be. So whenever we are running or whenever we are processing small a, then the corresponding ASCII value or decimal part of it would be 97. So, but my A would be the base here because every alphabet starts with A only. So A would be decimals, which is having 97. So, and there are 26 English alphabets. So my Z will be having 122. But if I wanted sole index of Z, then I could subtract Z from A because A being the base having 97. So Z minus A would return me 25 in the sense that we are using zero based index array. So Z should be 26 letter and we are okay with the condition. So I'm just taking 26 size and I'm iterating through every character within the word and count of ch minus a. I'm pretty sure now you might have got why ch minus a is being done because a being the base to get the relative frequency index. I'm just subtracting a character out of it and I'm incrementing the count so to find the number of times the key is pressed as in the word. So now I'll just short count dot begin followed by count.n. I'll just do this R to get the array sorted in the reverse order. Now you knew that we have how many keys? 1, 2, 3, 4, 5, 6, 7, 8 keys. We have 8 keys where alphabets can be mapped to. And all these 8 keys are having 3 letters which give us 24. And 2 keys are having extra 2 letters. So we'll be having 26 letters in total. So as every key is having at most 3 letters and there are 8 keys for us, what I'll do is first I'll take an int and I'll call it start. That's to be 8. Okay. Now for I'll just iterate into elements again. Count. I just sorted in the reverse order, right? I also call an answer. Yes, I'll just call an answer as well. Answer would be equivalent to 0. Why I'm taking this start? Because there are in total 8 keys, right? So I'm calling it as start value, which is having all the 8 keys. So for auto element in count, if element, no, if start, yes, if start is there, then what I'll do is, and I'll also add it over here int count, no, not count, int cnt to be 1. Okay, just like let me explain you why I'm taking this. Start equal to 8 is considered because there are in total 8 keys. Answer is to store the number of times that needs to be pressed or the number of times keyboard or mobile needs to be pressed to get a word in a minimum number of times. And count is 1 is taken because initially for or maximum number of counts that are present, I'll keep everything in every different letter. So I'll keep 1 in 2, 1 in 3, 1 in 4, 1 in 5, 1 in 6 because we are already sorted in descending order. So instead of keeping them on the same letter, I'll keep them on a different numeric characters of my mobile. So my count is 1 initially. And when start becomes 0, my count will be 2 and again start will be initialized to 8 because then I already kept all my characters, 1 characters that are repeating most number of times, 1 time. Now I'll need to keep it for the second time and for the second time again I'll start from 2 till 9. Right, so I'll just, what I'll do here is answer would be equals to element into, sorry, answer would be plus equals to because I'll need to aggregate the count that's present till now also. count into element start minus minus. So if my start suppose is equals to 0, I'll just check that at the above condition. If my start is equals to 0, my start would be 8 again and count would be plus equals to 1. I'll just return the answer from it. I'll just check if this is working fine or not. Yes, this is working fine. Let me also add the condition to not load the C libraries into C++ as we aren't taking in or taking out anything. We are just returning. So I'm just specifying that I am not considering the input taking and output taking. So do not tie those libraries while compilation. So I'll fairly reduce my time taken to run the program. Got it. So let me explain this part again if it's not so clear. So now we already have all the characters that are sorted by frequency in decreasing order. Now there are 8 keys that we can consider to remap these alphabets into. Now we already have the count in the decreasing order sorted. So initially there will be all the 8 keys present, and initially the count would be 1 to press that character. This count represents the number of times a particular character needs to be pressed. Right, got it. So if my character needs to be pressed this many number of times, initially I have all 8 keys. So I'm just iterating to my count and I'm checking if my start is 0. If my start is 0 in the sense that I already reached 9 and I already get the character over there. In that case, again, I need to go to 2. So my start would be 8, and now to press a character, it would take 2 count because 1 count is already sufficed and now 2 count will be taken. And now my answer would be how many times or how many times in the current iteration should I press a key followed by the number of times that element is present or the character is present. And now I will just decrease my start because I kept one character on this key. So let me submit this out. Great. We bet 99.61%. We are fairly good enough over here. So just do let me know if you feel anything is unclear. I'll just try to explain it again. Thanks a lot.